Welcome back to another installment of Ologies at Home. In this week's video, we are going to be taking a look at hydrology and some of the many ways water impacts our world, as well as the scientists who study it. Thank you for joining us for the final of this 6-part series, and we hope you enjoy the video. The word hydrology comes from the Greek root hydro, meaning water, and of course, ology, meaning the study of. In short, hydrology is the scientific study of the movement, distribution, and management of water on Earth and other planets, including the water cycle, water resources, and environmental watershed sustainability. Now, that's a pretty big topic, but water is so important to life on Earth that it warrants such intense scrutiny. Humans have been trying to understand the many aspects of water and water management for millennia, with the earliest known records of this dating back thousands of years. Ancient Egyptians dammed the Nile River to improve their agricultural endeavors on otherwise barren lands over 4,000 years ago. Roman aqueducts, tall stone constructions built at a gentle slope to divert distant water sources to where they're most needed, have been found dating back as early as the 7th century BC. Even the water cycle itself is ancient. The first record of human interest comes from a Roman man in the 1st century, Marcus Vitruvius, and was then later refined by Leonardo da Vinci before finally being quantified by more modern scientific testing in the 17th century. Every living thing on our planet depends on water in some way or another, so understanding its properties and how it moves and changes the world around us, how to keep it safe and clean, and its many uses is a very important topic that certainly keeps hydrologists busy. So, let's start by talking about some of the things a hydrologist does. Today, hydrologists are scientists studying earth or environmental science, civil or environmental engineering, and physical geography. Using various analytical methods and scientific techniques, they collect and analyze data to help solve water-related problems, such as environmental preservation, preventing and understanding natural disasters, and water management. To begin understanding how a hydrologist goes about their work, we first have to understand the water cycle. Water moves through our various planetary systems through many different pathways and at different rates. A hydrologist needs to know where water is coming from, where it is going, what impact it might have when it gets there, and what factors might impact its journey. Part of what makes water so interesting is the ease at which it can go from a solid to a liquid to a gas, based on Earth's environmental conditions. This ability to evaporate, condense, and freeze is the engine on which our water cycle runs. A water molecule might begin its cycle in the ocean and remain happily liquefied until certain factors such as heat, humidity, and wind are just right for it to evaporate and become a gas. Water in its gaseous form will rise in warm air until it reaches a point in the atmosphere where it is cool enough that these molecules undergo condensation and become clouds. As more and more water molecules evaporate, clouds grow larger. Eventually, the density of molecules is so great that water droplets form. This happens because of one of water's many properties, known as cohesion. It turns out that water is surprisingly sticky. Small droplets might remain suspended in the atmosphere, but at a certain point they are simply too heavy to remain aloft and will precipitate back to Earth as either rain or snow. As water falls back to Earth, hydrologists really get to work. A hydrologist who studies civil engineering might be interested in knowing how much water might impact a city sewer system to make sure it doesn't flood, or to understand how much capacity a levee, reservoir, or dam needs to have to keep nearby cities and towns safe. A hydrologist who studies physical geography will be looking closely at flow rates throughout a watershed, so that we can better understand erosion, flood risks, and to monitor droughts in areas where water supply is limited. Hydrologists also have a very important job of monitoring water health and pollutants to make sure water sources are safe for the people and other creatures who need them. In the Dayton area, all of our drinking water comes from a natural formation known as the Great Miami Buried Valley Aquifer. This aquifer is made up of buried sand and gravel deposits left here when the last of the Ice Age glaciers began to melt and recede, and is replenished by water seeping down into this porous structure. It can hold up to 1.5 trillion gallons of water. That might seem like a lot, but this aquifer provides water for over 400,000 residents, and the city of Dayton's wells can extract up to 2,500 gallons per minute per well. It's very important for all of us that hydrologists keep a close eye on how much water we use and how much is replenished with each precipitation event. We keep a close eye on the water in our parks as well. Keeping our creeks and ponds clean and healthy is very important. both for residents who want to explore them and for the plants and animals that rely on them too. Clean, healthy waterways help the environment in more ways than just providing a drinking hole for our local deer. It impacts soil and plant health, the quality of water in our underground aquifer, and even the health of distant oceans. Some of the most important factors in this are understanding agricultural and manufacturing runoff, and making sure to clean up litter and trash whenever possible. Our parks lay in the Great Miami Valley and Little Miami Valley watersheds, which are part of the Ohio watershed, which is part of the Greater Mississippi River Drainage Basin. What that means is that pollutants or litter that make their way into our parks could, and very well might, reach the ocean one day. Remember when we said water was sticky? It doesn't just stick to itself through cohesion. It also likes to stick to other things through a property called adhesion. We see this in dewdrops on grass and raindrops dangling on the tips of leaves. But water can also adhere to much smaller particles as well, and this means carrying pollutants such as small plastic fragments, fertilizers, pesticides, and herbicides far from where humans might have initially placed them down. Because of this, keeping water clean and healthy can be a tricky task, but hydrologists do their best to monitor waterways and intervene when and where they can. The United States Geological Survey has water monitoring stations all over the country, and there's even one station on Hulse Creek, which can be accessed on their website. Regular monitoring, both electronically and in person, helps provide data on water quality, rate of flow, flood stage, and more, and all of this aids us in understanding the health and safety of our waterways. There are also a lot of ways that you can study and observe water all on your own. The easiest, of course, is to head down to Hulse Creek at Grant Park or Sugar Creek at Bill Yeck Park at different times of the year. Look at how the creeks behave differently during dry spells in the summer and after heavy rains. You might notice them not only flowing faster or slower, but in different places. Pools of water might form or dry up, leaving behind different plants and creatures in their wake too. You can also observe the properties of water in your own backyard. After a cool, clear night, head outside at sunrise and see if you can find examples of adhesion on leaves or blades of grass. On a hot day, how long do you think it would take a cup of water to evaporate? Maybe you'd like to collect some data through a series of time-lapse photos and find out. There are lots of activities for you to experiment with in this Ologies activity PDF, so go check those out. And remember, as long as the days are warm, exploring in our creeks can be a fun way to seek out some hands-on investigations too. Finally, for one last time, I would like to thank everyone who has joined us for our first Ologies at Home series. From everyone at the Centerville Washington Park District, we hope these videos and activities have inspired a new curiosity in you and opened doors to the wide and varied world of natural sciences. There's so much you can learn both at home and in your own big backyard. We're always here to answer questions and help out in any way we can, so feel free to reach out. Thank you again, and until next time, we hope you have a wonderful summer.